Hope you guys are doing well. So continuing our journey in Swift, now we are going to position the elements, but before positioning, we need to learn something about some units in Xcode. Okay, now let's see about okay, now there is something called as CG point. Now CG point is basically having two components, X and Y, represented as CG float and values. Its purpose is defines a specific location in 2D space. It's commonly used in layouts, drawing operations, gestures recognitions, and animation paths. Now creating a CG point. The CG point is basically so does is so as we learned that so it's as we know, let's study about units in iOS. So we in the previous we studied the mobile can be divided as x and y into x and y coordinate. Now this is basically the origin, or where we say so this is the origin. This is 0, 0, and then you have two axes. So this is the x, and then this is x-axis, and then this is the origin. Now CG point. Now CG point, what does it stands for? So what is the full form of CG? Okay, now CG point is basically crow graphics points as the screen is divided into two axes. So the first thing that we're going to study is CG point, or code graphics. So as the mobile is divided into two as a 2D grid, so we have the x and the y axis. Now this is basically a struct. So like the struct which has two properties. One is x and one is y. This is basically indicates the type. So type is graphic float. Okay, now it is commonly used in layout, positioning, graphics rendering, animations, and transitions. So now, what if you want to move our? So by default it's centered, right? So if you want to move this, so then we can change the z stack location. Sorry, yeah, we can change the location by mentioning the city point. So what we'll do is we'll create a VStack, and then okay, so you have alignment, see how to move the VStack using CG. See, we want to move the VStack, so then okay, we have something called as positioning. So the way to move is just position, and remember this is the origin. So wherever we place it, wherever we point to, so we have a VStack, and then I have text, and then let's have a hello. Let's give it this is hello one, so let's have another text. Let's make this as hello 2, and then let's give this a background, and then let's pass in color, and then let's make this screen. So now we want to move this position, right? So we do dot position, and then basically it's a CG point, right? So when you have a CG point, we are going to so now by default it's placing it there because we are going to reset everything. So position colon. Now I need to mention X and Y. There is some issue. Cannot convert values of type int into XY argument CG point. Okay, so it has to be X. So now this X expects an X and a Y, right? Because it's a struct. So remember, the way we are going to do is position, and then it's kind of expects. Oh, so now pass in the so X is so X is 10 and Y is 10. So remember, we are going to place it from that. Now there is something called as safe area, right? So I do dot ignore safe area. Actually there is so if I place it, so it's going to work from here, right? This is how it's being calculated. So but then remember, this does not give us like the exact position, right? It's always kind of an irritating thing to use. So now we have something called as geometry reader. Let's see. The geometry reader in SwiftUI is a powerful container view that provides access and size to the position of its child views within their parent coordinate space. Okay, so let's so one thing is you use position that X, so this expects a CG point. Remember, CG point is the struct. It's an optional, right? Okay, so this is one method. The second thing is using geometry. And this is something. The geometry reader takes up all available spaces offered by its. Okay, now how the geometry reader works. Now, geometry reader is a powerful container view that provides access to the size and position of the child views within its parent coordinate space. So, for example, provides access to the size and the position of the views within the parent container. Provides this property like size, safe area. We can create responsive design using geometry. So basically, this will give us it will be with respect to the parent view, right? Okay, what it does is it's provide access to two things. The first is size, and second is position of the child view with respect to parent view. Okay, so now let's see how this works. So I have geometry. Now what does this? Now it kind of it takes in, it has a closure, it has two properties. It has a sorry, it takes in a property called as content, which is a closure. So since that is the last parameter, can we pass it? Okay, so then what we can do is we can make this as geometry reader, and then so let's define the function. It will automatically do that for us. So I have a content, and now so but this should be, there should be a should have a VStack or something inside this, and then we can write text and then say, and then it provides us two things, right? Height and width. So the construction type, what is this? For closures argument, which expects one argument which cannot be implicit ignored. It's taking in, let's see again the definition. Geometry reader. Now that takes in a content and returns a view, right? So I say geometry reader. This should be something. Okay, it's going to be a closure. So this is the closure, and then I have what is this? So this geometry. Then now I'm going to pass this view. So this is, let's get this thing out. So then let's take this, Control C, and then the VStack is coming here, right? Okay, now I'll have access to two properties. I can do slash geometry dot size. Oh, you see, it's exactly giving how big that how big the VStack is, I guess. This is the width, and then what if I just want to see the size? So then let's have this thing, and this is geometry dot size dot height. So I'm getting both, like the height and width. So let's say this is height 1, this height 2. So this is like, and what if we have an HStack here, and say I'm having 2 elements here. So now what is this? This is outside VStack, right? It's not. So remember, these two have now come the part of, and what if I put a, say I have a spacer in between. And so let's have this, let's move it down. Let's get this so this VStack is, yeah, right. So move it, so I can say position, and then I need x and y, right? So then x colon now, so the value of okay, I know. So this is geometry dot what if I want to move it? So if I say, well, it's x colon 10, y colon 20, say, and then this VStack is, it's here, right? And then let's give it a background of let's okay, so this, how is this? So the VStack is, why is it occupying so much space? Let's see what has happened here. Existence. So if I do geometry dot size dot width, size is going to work like, what's the, so I have a geometry reader, and then so this position I can give it as what if I want to move, so this is the HStack, it's getting so much, why? The horizontal stack is, let's add this as, I mean it's taking so much, why? Then just be color dot say, so, but why is my VStack so big? Why is it, I don't know. So what's the geometry reader takes up all the available space you can now access, you can impact high performance. What is the use of geometry? I mean, like, what's the geometry? Okay. So when I say position X, centering a shape, so I have now, oh, see, there's something, now remember that the okay, so the what's the parent view? Is the parent view, I need to be at the center, right? There's something I'm missing here. So GeometryReader takes up all the spaces offered by its parent. It gives access to geometry proxy, which provides details about the size and the position. Like, what's the parent here? Is it in the context? So this is by default the root view, right? I don't want this to be there. So what if I have a VStack here and I want my geometry to be inside of this thing? It's still occupying entire. Why do I have a VStack? Let's let's have some elements. So we have this VStack here. So let's give this high, and then let's have, so this is 2. Now if I put this geometry reader inside this, will it place? So I have a high view, and then what if I change the coordinates here? Say I say this is geometry dot width dot width. Now what it has done, and then I say this is summarize geometry dot size dot height. Just pushed it down now. What is getting pushed? And with respect to whom? And the color pink, where it is. I'm not giving. So is this geometry reader so big? Oh, I have a spacer, right? Let's get this thing. Why is it? Why is the VStack so big? In VStack I have two things, right? Height and which is this orange thing. What if I get in geometry that is directly in the root body? Its parent is the entire screen. Okay. So now this VStack, right? So a geometry root, then its parent is the VStack, which determines the available space. I'm going to set the height of this VStack. So let's have this frame. Let's just say this width is say 100. So the height is 100, and then let's make this. Let's remove the position and see what happens. And let's have this not 100. Let's make this. Let's have a big box, right? Let's give it a height of 50 and width of maybe say something like 2657 or something. What is the error? Syntax error. Expected separator. Let's take this up. So I have 100 comma. No. This is the VStack, right? Let's change the height and width of the VStack. So I have dot frame. Then I have height and width. Oh, I have it's width and height. Okay, so this is 7% frame. I say width is 100, and I say width is 1000, and height is 20,000, and then Okay, this is pink. Oh, and I suggest background is color. So this is going to be this big. No, let's okay. Let's say it's. So is it going to push that view? Oh, it's not coming on top of it. The problem is I have VStack, so it's kind of pushing it. If I want to have it on it, I'll have to put a HStack and then inside. So this is the VStack. Wow, okay, let's have an overlay on this. And then let's put on top of it. So let's do this. Now why is it still pushing it? So I have this HStack. Oh. So now let's give this HStack a color of say but why is the height going that side? I don't know. I given this a width and a height. The width is very small. So it's increasing in width this way. And sorry, this is the height, right? Let's no, it's what if this is 10 100 okay, so I have 100 and the size of that thing is, and then let's change the size of the frame height to be say, let's make it exactly on top. So if I say this width is 100 and height is say 200, let's modifies our axis to one after the other, right? So let's just view the exact height and width. Let's say this green. Oh, let's increase it a little bit because then you won't be able to see. No, let's start. Let's make this like 150, and then let this to be. Oh no, let's have this thing as 100, and then change this as 150 something. So that what am I doing? So this is width and width is 50. Let's make it 100 a little bit, and then I have frame that is. Now what I want to do is, what if we try to move the VStack? But I want to move the search stack. What if I do position? Now what if I do x colon? Say I do 10 and I do y colon 10. Where did it disappear? Went out. Right now it's x. Oh, this is the search stack. I need to move the search. So let's try to position. Try to move this little bit. So let's say I want to move it. So right now it's going to that X and Y. I need to do it with respect to, so I say geometry dot size dot, let's move it this much, and then y is x colon y colon geometry dot dot size dot height. So is this now what has happened? Remember this VStack, it's the pink one. So I have moved it with respect to the height and so let's see. So this is my geometry, right? So oh no, the parent is over here and I need to frame this. So what did I frame? This is the inner VStack, right? So when I do, let's give the outside the parent some frame, right? So I say this is frame. This is width. This is 100, and then this is background color dot gray. So when I set the width as this much, and let's change the height to say 90, and let's have wait right now greenish. Let's get rid of this. This is nuisance. So what do I have? Did it read under? Why is the green? So I have a pink and gray, and it is, and after all it syntax error. Oh yeah, let's get rid of this. Now the back is gray, and then there I have a pink box on which I have a green. And this is the green one. So now if I with respect to which I have moved this, let's see what which VStack am I moving. Let's see. The most parent container is the stack. So I have two texts. This one, the outer one is the VStack, and then it's GeometryReader, right? I give it a height and width. Okay. GeometryReader is placed inside the stack. Its parent is the stack. It will it will no. The VStack geometry. The stack has an height and weight. The geometry reader is placed inside the stack. Its parent is the stack, but it will take all the stack. Its geometry reader is also 100 cross 90. Inside that, I have a frame and height. The frame doesn't respect. So basically, geometry reader will take the entire space. The width of geometry. So I moved it 100x and 90y. So okay, so what if you want to center a circle? So then yeah, this is something. No, let's have a circle, right? And then let's give it. Let's resize it. Let's give it a height and a width. So I say width. By explicitly it will make the width. So I say this is 20. Oh, this is 90. And then the height. Height is 90. No, it assumes that the width and height is going to be this. Now I want to position this on center, right? So I say geometry reader, and then I say I put this thing inside, and I say okay. Then I say geometry in, and then I put a parenthesis. Now this circle, the build expression, unable to conform to view. This is a shape, right? This has to be a view. Select how to center a circle using geometry reader. To center a circle, okay. The first is I define the height and width. And then I have a geometry reader. So geometry in, and then this is the circle. Perfect. Oh, wrong parenthesis. This is not a stack. This is closure, right? This indicates that I just so place the element to the exact center of the screen. If this is the height, this is the width, the exact center will be, I say x colon geometry dot size dot width by 2, like whatever is the, and then the height will be, sorry, it's y. So this I'm doing positioning right, and y is geometry dot size dot height by 2. This is the exact center of the screen. This is the x, this is the y. So even is there a way to print something? Just print work in here. So if I do print, cannot preview in this one syntax. Cannot find geometry in scope. Consecutive statements on a line must be. So I said print I. Cannot find geometry in scope. Let's get this thing down. Build expressions and implement. What if I store it in? That expects something to confirm, right? This will be the exact center though, but how should I? Can I? Oh, I can see it here. There's one more way to see the exact center. No, I forgot. Get this thing here. Let it be beside my. Oh yeah, this is what I was saying. So if I say about Does it tell the does it tell the location? No. So let's move this up. Let's have it. Remove the canvas down. How should I move it? Oh yeah, this size. And then also problem is when I go to no, just increase the size, it will come up. I say no. Let's get rid of the assistant. Show canvas. And then canvas under it. Then yeah, this is basically going to, so the parent view is going to be the entire size. This is kind of good, right? We don't know what exactly it is. The advantages, we don't need the exact values, like the GeometryReader will give us the values. That's like an advantage. Yeah, we are not hard coding the values, so then we have something called as lazy grid. We haven't studied grid though. Oh, we did list views. Then we need to create a scrollable thing. Tabbed. Geometry is done. Then now let's see something. These are all container views, right? Let's see. We haven't done it for navigation. So shapes is a view, or navigation should come in navigation view, right? We haven't started about modifiers. No, this is binding. There's something. So when I gave it a, let's just get rid of this binding thing. This. So when we let's study about certain modifiers that we can apply. So there are layout modifiers that affect the layout, such as foreground, background, blur. How much blur do we want? Border and padding, right? So how is the border and padding defined? Like, how do we check? For example, in Swift, does it have like how to imagine border and padding like the box model in CSS. I mean, is there something like that in SwiftUI? Replace the CSS box, right? Mm. Mm. Okay, so how? But this is CSS border. How is CSS very different? iOS, sorry. Border. Let's see. I need a visual representation of border and padding is in CSS. I mean iOS. Border and padding in Swift. How is this looking? This is it kind of adds like a outline just like this. I'm used to each view as a padding. Does it have a different name? Is it the same thing? No need for them in SwiftUI. You can apply multiple paddings. So how is the so how is it in Swift? The box model row is not much here to learn. This is actually when we go ahead when the scroll level is a content to you. I still doubt. It is only the stacks or the content container views, right? Yeah, VStack, HStack, ZStack. It's container views in Swift. VStack, then I have HStack. Oh, spacer. Spacer is something that I need to. GeometryReader. Scroll you does come here. List is done. Oh, now, yeah, one thing I didn't really use our spacer. Okay, now in SwiftUI, spacer is used to create a flexible empty spaces between the views in the layout. Okay, so by pushing the views apart or aligning them with a container, like, can we mention how much so fills the remaining space? What does it do though? Suppose I have an HStack. Let's see. Well, let's see. So, okay, this is container alignment and I have units. Let's see one thing. Spacer. This is important. So, spacer. Now, what does it do? Okay, so spacer divides the available space evenly, pushing child views apart. So a spacer is used to create a flexible empty space between views. It allows you to control spacing dynamically by pushing the views or aligning them with a container like HStack or VStack. So a spacer is to now. So the work of, I mean, how it is used. The waiver or spacer changes where it is used. Its primary rules remain the same to create a flexible. Now there are different ways and context. Okay. So the goal of spacer is to create flexible space. Then the behavior of spacer changes depending on how it is used. So then let's so first is equal spacing. Equal spacing is between. So for example, I have a text here. So come here. And this parenthesis text left spacer, and then so this is equal spacing. And then so then is occupy remaining space. So this is again let's then multiple spaces are inserted to divide the remaining space appropriately. If I want to occupy remaining spaces, so so I'll say I have this X and then text, then have a spacer, then text. So no, this is, so yeah, this is going to occupy remaining space. This is a struct, remember. Let's see the syntax, what it does. So space. Okay, that's an optional value, a minimum length, a flexible space that expands the major axis of its containing. So there are two axes, right? What's the major axis? Oh yeah, it's so the spacing is applied along major axis. Remember. This thing is important. So can I Let's get this thing a little bit. Let's have a page. Let's so I see. Start space along the major axis. So then some major axis. So I can have 3, right? HStack X is the major. VStack Y is the major. And then ZStack it becomes Z axis. Dynamic spacing, yeah, depending how. And then I haven't studied frame yet. It's a modifier. We'll see that later on. So is spacer a view? Yes, spacer is a view. Conforms to the protocol. So it does not render any content though. Then what else is the? I guess yeah, that is all for this lecture. See you guys in the next one. Thanks. Bye bye. Take care.